On the night of 7 September, nearly 77% of the world's population will witness the moon turning red. The eclipse will begin with a penumbral phase at 15:28 UTC, and by 16:27 UTC, the moon will start taking on that rusty glow, a glow that will last for about 1.5 hours. When I was a kid, I was told that lunar eclipses only happen when the sun, earth and moon fall into a special alignment and the earth's shadow covers the moon. Although correct, but it doesn't really explain everything. For example, under what exact conditions do the sun, earth and moon align so that a lunar eclipse can actually occur? What is the duration of eclipses change, and why are some partial while others are total? And the most fascinating question, if the moon is inside Earth's shadow, why it doesn't just vanish into complete darkness? Why does it glow with that deep rusty red instead? To answer all of this, we need to see the bigger picture, the geometry, the atmosphere, and the way all three bodies move together to create this cosmic event. Coming to our first question, the plane in which the Earth revolves around the Sun is called the ecliptic plane. Now if the moon's orbit were perfectly aligned with its plane, we would get a lunar eclipse at every full moon. Earth's shadow would fall directly on the moon every single month. But here's the catch, the moon's orbit is tilted about 5 degrees from the ecliptic, and because of this tilt, the moon usually passes above or below Earth's shadow. There are however two special points where the moon's orbit actually crosses the ecliptic plane. These are called the lunar nodes, and when one of these nodes line up with the Sun and Earth, something magical happens. If it's a full moon, Earth's shadow falls on the moon, a lunar eclipse, and if it's a new moon, the moon's shadow falls on the Earth, a solar eclipse. So now you understand when eclipse can happen, but that raises another question. If lunar eclipses are all about the moon passing through the Earth's shadow, then why do we get partial eclipses sometimes, and why do some last much longer than others? The answer is actually simple. The moon does not always pass through the center of the Earth's shadow. When it does, we get the longest and most complete lunar eclipse. The moon spends the maximum time glowing that deep rusty red. But if the moon's path is slightly offset, only part of it slips into the shadow. That's when we see a partial eclipse, and the red glow lasts for a much shorter time. Now to our last question, why does the moon turn red instead of just vanishing into darkness? Here's the reason. When sunlight passes through the edges of Earth's atmosphere, the shorter wavelengths like blue and violet get scattered away. By the time that light bends around Earth and reaches the moon, most of the shorter colors are gone, and the longer wavelengths, the deep reds and oranges, are what remain. It's the same effect you see during sunrise and sunset when the sky glows in shades of red and orange. So this September 7, when the eclipse takes place, take a moment to look up. What you will see is more than just a rusty moon. It's the Earth's atmosphere projecting its color onto another world.